Good morning, everyone. Today is Wednesday, April 8th, and today's topic is exponent laws. There are three laws that I'm going to go over. The first one is product of powers. The word product means multiplication, so I'm going to show you what to do when you're multiplying powers. What do you do with the exponents? Quotient of powers. Quotient means division. And then powers of powers, so taking a power and raising it to a second power. Alright, so the first one is product of powers, and what we're going to do first is we're going to take 2 to the exponent of 3 and 2 to the exponent of 5, and we're going to write them in expanded form. Okay, so 2 to the exponent of 3 means 2 times 2 times 2. And 2 to the exponent of 5 means 2 times 2 times 2 times 2 times 2, so 5 2's altogether. When you add them together, or multiply them together, how many 2's do you end up with? 8. Okay, so a simplified way of writing 2 to the power of 3 times 2 to the power of 5 would be 2 to the power of 8. Right, quick way to get to the answer would be just to add the exponents. 3 plus 5 gives you 8. Okay, second example, 5, and the exponent on the first 5 would be 1. Okay, we don't bother writing it, but we know it's there. And then 5 to the exponent of 7 means you're just multiplying together 7 5's. So all together, you have 8 of them. Okay, next one is -4 to the exponent of 2. Alright, notice the bracket is on the outside of the 2. Okay, so you're only squaring the 4, not the entire thing. And I'll show an example at the bottom here, the difference between squaring a -4 that's in a complete bracket compared to squaring a -4 that doesn't have a bracket. I'll do that in a second. But this is -4 times 4, and then if you have a 3 exponent, it's -4 times 4 times 4. So altogether we have 5 4's, and there is one negative sign multiplied with a second negative sign. When you have negative times a negative, that becomes a positive. And the last one, -7 to the exponent of 3, so you're writing -7 in a bracket 3 times, multiplied by -7 squared. So you have 2 -7's in brackets at the end here. All together we have 5 of them. Okay, so now at the bottom here, this part you don't have on your sheet, so you can add this to the top of your handout as an extra example. Okay, notice the difference. The first example has brackets, and the second example doesn't. Okay, when there are brackets, you're writing the entire thing 2 times. Right, -4 times -4. Negative times a negative is a positive, so it's positive 16. Second example doesn't have a bracket, so you're not squaring the entire thing. You're only squaring the 4 that's right below the 2 with one negative sign in the front. Okay, so essentially this is -4 times +4, which is -16. So brackets matter. Okay, so to summarize the product of powers rule, when you're multiplying a power with the same base, we keep the base the same and we add the exponents. Okay, so generally, just to generalize, if the bases are the same, so you have an A and an A, and we are multiplying those together, what you're going to do is add the exponents. Okay, so rewrite the base, A, and then add the exponents, n plus n. Second rule, quotient of powers. Okay, and that one says if you are dividing, okay, powers with the same base, you want to keep the base and subtract the exponents. Alright, so we're going to subtract m and n. So m minus n. And let's show that this is true. That's what I'm doing in this down here. Okay, I'm going to show that they are true. So I'm going to say let's pretend that m is equal to 9 and n is equal to 4. Okay, so I'm taking the first part of the equation, replacing my n with 9 and the n with 4. I'm expanding it. So at the top I have 9a's, at the bottom I have 4a's. And we can cross some of these off. Okay, these will cross off. And how many a's am I left with? 1, 2, 3, 4, 5. Okay, so that shows you that a over a to the 9 divided by a to the 4 is equal to a to the 5, okay, by using expanded form. If we use the quotient rule says you can subtract the two exponents, and our exponents are 9 and 4, so if you subtract them you end up with a to the 5. They are equal to each other, okay, therefore those equations are equal. And the third rule is powers of powers. When there's a power of a power, we keep the base the same again and multiply the exponents. Okay, so our base is a and our exponents are n and m. So we're going to check to see if this is true. Okay, we're going to prove this rule. I'm assuming n is equal to 2 and m is equal to 3. I just made those numbers up. Okay, replace your n and m in the equation here and write this in expanded form. Okay, how will we write this in expanded form? It's a squared to the power of 3. That means we're going to write 3 of these. Right? A squared, we're going to write that 3 times. A squared times a squared times a squared. And what is a squared equal to? A times a. Okay, so altogether I have 6 a's. So this is equal to a to the 6. And the powers of powers rule says you multiply the exponents when you have powers of powers. 2 times 3 is 6. Okay, they're equal to each other, so the rule is correct. Okay, on this page here, so we're on page 7, just some examples. You're just simplifying, you're not evaluating. I'll show you what evaluate means in a second. Okay, so simplify, so we have 9 to the 7 multiplied by 9 to the 13. Okay, we're going to add the exponents because there's multiplication in between. Remember the rule, we have multiplication in between, we add the exponents. If there's division in between, we subtract them. And if we have powers of powers, so 2 exponents like this, we multiply the exponents. Okay, so for the first one, I'm going to add the exponents. 7 plus 13 is 20. Second one, I'm going to multiply the exponents. 2 times 6 is 12. Right, notice I'm showing my work in the first line and then my answer in the last line. It says do not evaluate, so I don't have to find what 6 to the power of 12 is. I'm just leaving it like this. Third one, division, we're going to subtract, so 9 minus 4 is 5. The bases are not changing, right? I'm keeping the base the same, just working on the exponents. Example D, negative 3 over 4 to the exponent of 2 multiplied by negative 3 over 4 to the exponent of 7. Right, so if they're being multiplied, we're going to add the exponents. 2 plus 7 is 9. Okay, notice nothing in the bracket changed, right? My base is not changing. You don't have to worry about that. Just worry about the exponents. E, 2 times 3 would be 6. So x to the exponent of 6. Okay, so now we're introducing variables. All right, what happens with this one here? That 2 gets multiplied by the 3 because we have powers of powers. Okay. Okay, but that 2 also acts on the exponent on the 4. Right? What is the exponent on the 4? The exponent on the 4 is 1. We don't have a 1 there, but we just assume there is a little 1. Add a little 1 there. Okay, so 1 times 2 is 2, so the exponent on the 4 now is a 2. And 2 times 3 is 6. Okay, G, multiply 4 times 2 and multiply 7 times 5. and then in the last line, so what I've done here is I've done the powers of powers first, okay, and then I have the product rule here, right, because the bases are still the same, they're y's, and now there's multiplication in between, which means I'm going to add my exponents. 8 plus 35 is 43. And the last one, I'm going to worry about the powers of powers first, okay, and then the quotient rule. 7 times 8 is 56, and 3 times 13 is 39. And now the quotient rule says to subtract the exponents. 56 minus 39 is 17. And that's it. And the last example, example 5, there's 3 parts to that. It says simplify each of the following and then evaluate. Okay, g equals 5, h equals -1, and k equals 2. So we're going to simplify first before we evaluate. Okay, so how do we simplify h cubed to the 7? Powers of powers here, 3 times 7 is 21. So we have h to the 21. Okay, and the second part now says evaluate if you have a g, h, or a k, replace them with correct numbers. So we have an h here. I'm going to replace the h with -1. Alright, so keep it in a bracket. Okay, we have -1 to the power of 21. Since this is an odd number, we're going to get a negative answer. Okay, this is essentially saying what is -1 times -1 times -1, okay, 21 times. If you, just to kind of explain why that's happening, if you have -1 and you square it, okay, that means -1 times -1. Negative times a negative gives you a positive, so the answer is positive. What if you have -1 cubed? Okay, that means -1 times -1 times -1. Okay, these two are going to give you +1, and then you're going to multiply that by the last -1, and so now you have a positive times a negative, which gives you a -1. Right? When you do the next one, I'm not going to do all of them, but I'll do one more. The next one would be a 4, right, which would be an even number. It would be -1 times -1 4 times. Okay, what's happening here? -1 times -1 gives you +1, and then over here -1 times -1 gives you +1. So you're left with +1 times +1, which is a positive. See how they're alternating? Right, so every time you have an even exponent, the answer is going to be positive. If you have an odd exponent, the answer will be negative. Okay, that's why here the answer is -1, because we have an odd exponent. J, powers of powers, right? 2 exponents, so 3 times 3 is 9, and 3 times 2 is 6. And now you've got the quotient rule, which says to subtract the exponents. 9 subtract 6 would be 3. And now evaluate if k is equal to 2, so replace your k with 2. So you've got 2 cubed, 2 times 2 times 2 is going to be 8. And the last one, k, g to the 11th to the 2, so powers of powers here, another powers of powers, and another powers over there. So I take care of the powers of powers first every time. You're multiplying the exponents. 11 times 2 is 22, 3 times 7 is 21, and 7 times 6 is 42. Now you can worry about the product rule and the quotient rule. Alright, so quotient rule says to subtract your exponents. Alright, we're only able to do this if the bases are the same. So these have the same base. Alright, so 22 minus 21 is 1. Okay, so now I have g to the 1 times h to the 42. There's a product rule here, but these have different bases, which means we can't use the product rule. Okay, so we are finished. We finished the first part. We've simplified it. This is as far as you can go. Now we can do the evaluation. Replace your g with 5 and replace your h with -1. Make sure it's in a bracket. Okay, so we have 5 to the exponent of 1, -1 to the exponent of 42. And over here I explained if you have an even exponent, the answer will be positive when you raise it to that power. So 5 to the 1 is 5, and this is going to give you +1. 5 times 1 is 5. Alright, so those are all the examples for homework. We're on page 55 in your workbook that you brought home with you. These are the questions that I'd like you to complete before next lesson. Our next lesson is not until Wednesday, April 15th, because we've got Easter weekend this weekend, right? Friday there's no school, Monday there's no school. So our next lesson is not until next Wednesday. So you got lots of time to complete this. I am checking my email regularly, so if you have any questions, please feel free to email me. There's been several students who sent me messages. I try to respond quickly. Make sure that you're checking your Google Classroom every single day, your student calendar. There's a new one that we posted, and check your Gmail. So we're going to work on algebra for the rest of month of April, and I've scheduled our first test to be on Friday, May 1st, and that will be an online test. All right, good luck with all the work, and send me a message if you have any questions. Bye, guys.